Hello. Uh, the structural analysis have been done in my videos from serial number 1 to 6. From that, we have already calculated the bending moment in slabs, beams, and etc. Direct loads on columns, the shear force on beams, on slabs, and etc. have already been calculated uh, in the videos number 1 to 6. In video number 7, we have already seen this design of two-way reinforced slabs. Now, in this video, we are going to see the one-way reinforced slab using IS456 and design aids to IS456. In this design of slabs and suggestion of reinforcement in slabs that needs a certain practical knowledge also. The slab design will give a very less reinforcement only. As per theoretical design, the reinforcement coming from theoretical calculation will be less, but as per practical condition, the reinforcement will be much more than the design result. So accordingly, if anyone likes to design any slab and likes to give a suggestion to the construction people, please make a note of this. Please continue this video.
So the design of RCC floor slab, calculating the depth of slab. The name of slab is panel number 2. This is panel number 2. We have already discussed in the previous session. The short span length LX is 2.7, the LY is 6.4 meter. Here we have the standard data. The working or service load is 7.3 kilonewton per m square. The grade of concrete is M20, grade of steel is FY 500, FE 500. The slab is rested is as a is existing as a continuous slab. As per class number 2321 of IS 456 for the safety against deflection, the span by effective depth is equal to 26 into modification coefficient. Here that is 23 2 bar 1. The basic value of span to effective depth for spans up to 10 meter, the continuous 26 meter, then this can be multiplied by the modification factor. Modification factor are given in figure number 5. We can see those things later. By applying the modification factor, this comes as 26 into modification factor, this comes as 32. So the effective depth is equal to 2.74 is the short span. Short span this is in meter, this multiplied by 1000 gives into mm. This becomes mm. So into 31.5 equal, this is 86.31 is the calculated depth of the slab. So add 20 mm cover to reinforcement. The total comes as 106.31. 110 mm or 4.5 inches. The above depth is applicable to panels 1, 2 and 10 only. These three panels are the one-way reinforced panels with the same span. So this depth of 110 mm is applicable to these panels only. Depth of other panels are 130 mm. They have already calculated in the previous videos. So the depth difference between these two is only 20 mm. Because of this 20 mm difference, we are going to make a savings of 0.5 cubic meter of concrete only. This is very less. So we shall take these things. 130 mm, we shall take the same depth. Here we are going to see the calculation of maximum bending moment and reinforcement in the slab. The given figure is the name of the slab is the number 2, the span Lx is this much, and the Ly is which we saw a little before. So from this, the given items, the working stress is the working service load is 7.25, M20 concrete, Fe 500 steel, The slab is supported on three sides and one edge is discontinuous. From the working load, we are arriving this factored load, which is multiplied by 1.5, 7.2.1.5 equal to 10.875 is the design load or the factored load. Now we are going to calculate the Ly by Lx. What is this? It is 6.4 is the long span moment. Long span, this is short span. Total is 3.2, 3.33. So this value is more than 2, then this has to be designed as a one-way reinforced slab. Maximum bending moment in the slab may be calculated considering 1 meter width as the beam. Maybe this may be considered as a beam of size 1 meter width and the depth as we decided previously. That is 130 mm depth. Here, this bending moment for the beam is WL square bar 8. This is 10.87 into 2.74 into 2.74 by 8 equal to 10.205 kilonewton meter. For this moment, we are going to design. Now, we are required to see the scene in the book Design Aids to IS 456. This is the book for design aids for reinforced concrete to IS 456. This is the chart we are required to see. The maximum bending moment we have calculated is 10 point something. So we can this curve is for this 10 kilonewton meter bending moment in a beam. Singly reinforcement. The x-axis indicates the percentage of reinforcement. The y-axis indicates the depth of slab. So for this, our depth is 11 centimeter. This is 11 centimeter. So 11 centimeter to this much gives this 0.2 something. It comes out as per the chart. In deep calculation, the percentage of steel reinforcement from the above chart, it is 0.23%. The size of the beam or the portion of slab which is taken as 1000 mm into 110 mm into 0.23, the percentage gives this 253 square mm rod is required there. Considering 8 mm diameter rod, this rod area is this much. Number of rod required for 1 meter or 1000 mm is this much. And so by dividing this 1000 mm into number of rods required for 1 meter is 198.65 mm is the spacing of the reinforcement as per the design, as per the actual calculations. But there are certain things required to be observed as per a practical condition. In practice, maintaining the thickness is a little hard thing and the reinforcement position generally gets changed due to the working of the concrete laying persons and due to the impact of concrete laying machines. And also sometimes voids happen into the concrete sometimes and which may give a little porosity and giving rise to penetration of water which may cause a corrosion in the steel. So practically we need to give some extra provision for that. Therefore, to avoid loss of strength in the slab, practically 10 mm diameter is generally provided as the main rod. This is generally adopted in all buildings which are found to be said to be a quality building. So adopt a 10 mm rod at 180 mm spacing, center to center spacing as main rod. Previously, we have calculated this as 8 mm rod at 198.65 mm. 8 mm rod at 198.65 mm is the theoretical requirement, but practically we can make it as 10 mm at a spacing of 180 mm. that is 7 inches center to center. This rod is generally adopted in all practical buildings, which is considered to be a quality building. Next, we are coming to distribution reinforcement. How to calculate the distribution reinforcement depends on two or three factors. The minimum reinforcement in a slab should be 0.15% as per class 2652 of IS 456. Here, this is IS 456 page 26521. Minimum reinforcement is given as, see here, the mild steel reinforcement in either direction in a slab should not be less than 0.15% of the total cross-sectional area. However, this value can be reduced to 0.12% when high-strength deformed bars or welded wire fabrics are used. Now we shall go to that maximum percentage, which is 0.15%. Also, this has to be considered that hogging moment, that is, negative moment, may cause even in long span at the place of supports. So, considering theoretically worked out reinforcement for short span, in practice, the space of the rod are kept not more than 2.5 times. This is also a practical thing. In IS 456, this has been given as 3 times the depth of the slab. In practical condition, this should not be more than 2.5 times the effective depth of the slab. The distribution reinforcement should not be less than half of the main reinforcement. This is also adopted in practical conditions. Adopt 8 mm rods at 180 mm center to center as distribution reinforcement in long span. In short span, we have already provided 10 mm rod at 180 mm center to center in short span. This we are providing this 8 mm rod. This is which is not less than 50% of the short span reinforcement. This is a practical thing. Being a senior engineer and having a very good experience in construction, I like to suggest you to provide both the rods as two-way reinforced slab actually. The hogging reinforcement has to be provided. I have seen in many buildings wherever the hogging reinforcement is not given in long span, the cracks are found within 4 or 5 years. So provide a top rod in long span. So instead of providing an additional reinforcement, crank the long span rods similar to the rods given in short span.